Okay, so today we are going to cover the basics or foundation of organic chemistry. So we can start with hydrocarbons. So from the name, these compounds including hydrogen and carbons. So from hydrogen and carbons. So we can classify this big group into three. First, alkane, alkene, and alkyne. The suffix is very important, A-N-E, E-N-E, Y-N-E. So the general molecular formula for alkane is CnH2n plus 2. What does that mean? You know, any carbon atom must be surrounded by 4 bonds. Okay? So first member of alkane is CH4, carbon attached to 4 hydrogen atoms. And this is called methane. So one is meth, so methane. And the second member is CH3, CH3. This is called ethane. And if we combine them, it will be C2H6. What's the difference between the two members here? 1 carbon and 2 hydrogen, so CH2 group, right? This is the difference between them. And both have the same general molecular formula. Cn, here C1, and N is 1 again, so 2 times 1 is 2, plus 2 is 4. And here, if N is 2, 2 times 2 is 4, plus 2 is 6. This is ethane. Third one is C3H8. This is called propane. Again, what's the difference between ethane and propane is CH2 group. So this is why it's called homologous series, because all of the members have like constant units between the members. Okay, the second class under hydrocarbons is called alkene, has the general molecular formula CnH2n. So 2 hydrogen missed here. And we have here double bond. So any alkene must have double bond. This is why the first member cannot be 1 carbon, because the double bond must be between 2 carbons. So the first member, which should be CH2, it's not a compound, it's just a group. But the first member is CH2, double bond CH2, or general or molecular formula is C2H4. What's the difference between that and that? This is molecular formula, and this is called structural formula. Okay? And general molecular formula, N is 2, and 2 times 2, 4, C2H4. And this is called ethene. So look, we replaced A-N-E with E-N-E, and this is why it's called alkene. But also can take a common name. And instead of ethene, we can call it ethylene. This is a common name. It's called ethylene or ethylene. And this is why, look, if you look at CH2, it has the same general molecular formula, CnH2n, but it's not a compound, it's just a group. This is why we call it methylene group, because it's same like alkene, Y-L-E-N-E, but it's not alkene. Just we call it methylene group, CH2 group. Okay, but this is a group, not a compound. The next member of alkene is propene, CH3, CH, double bond, CH2. So this has general molecular formula C3H6. What's the difference between them? again CH2 group, methylene group. So this again homologous series. All of them are homologous series. So 3 carbon called propene or propylene. Propene or propylene. Okay. And the third class is called alkyne and also start with member with 2 carbon. Okay, and we will replace A in E with Y in E, so it will we'll call it ethyne. Ethyne. Okay, so it has triple bond, but the common name is acetylene, and this is a gas, acetylene. Acetylene gas. Okay. Next member is CH3, C triple bond CH, and this is called propyne. And general molecular formula is CnH2n minus 2. So if you apply this general molecular formula, you will find it here and here. And next also. Why here carbon attached only to 1 hydrogen? Because as we said, each carbon has 4 bonds. So 3 bonds here and 1 bond other side. And if you have multiple bonds between 2 atoms, one of them must be sigma bond, and the other are pi bonds. Pi bonds are weak bonds. Okay. Okay. Let's go more in details about nomenclature. But before we move that, what about if we have CH3? How many bonds left for carbon atom here? 1 bond, right? So this is a group, not a compound. This is a group called methyl group. Methyl group. And the name coming again from alkane, but replacing A and E with YL instead of methane, methyl. And if we have CH2, CH3, and bond here, what's this called? It's coming from ethane, replacing A and E with YL, so it's called ethyl, ethyl group. Okay, let's do something more tricky. What about if we have something like that? CH3, CH, CH3, and attach it from here, or CH2, CH2, CH3, and attach it from here. What is the type of this carbon, for example? The type of carbon depends on how many carbon attached to it directly. So how many carbon attached to this? 2. So this is a secondary carbon. But this carbon, how many carbon attached to it? Only 1, directly 1. Don't count all of the carbon, just directly 1 carbon. So this is primary carbon, and this is secondary carbon. So if the propyl group or propane attached from secondary carbon, what's this called? This group, what's this called? So this is propyl because it's attached from primary carbon. It's called the propyl group. Propyl group. What about this one? If attached from the secondary carbon, it's called isopropyl. Iso means like. So isopropyl. So you need to know that the secondary carbon of propane, if it's attached from it, it's called isopropyl. Let's have a let's look at butane. CH3, CH2, CH2, CH3. This is butane, right? Butane. But if it's a branched, like this, CH3, CH, CH3, CH3. This is normal butane. N-butane means normal butane, means linear butane. But this is branched butane. So we can put B small butane, branched butane. How many types of carbon in normal butane? 2 types. We have 2 primary carbon and 2 secondary carbon. And how many primary hydrogens in normal butane? We have 6 primary hydrogen. Primary hydrogen atoms means attached to primary carbon. So we have 3 primary hydrogen and 3 primary hydrogen. And we have 4 secondary hydrogen atoms. Okay? But in isobutane, this is called the branched butane or isobutane. Isobutane has 9 primary hydrogen atoms. And only 1, you know what's the name of this hydrogen? Tertiary hydrogen, yes. So it has only 1 tertiary hydrogen. Now if we take one of these primary hydrogen, what's the name of the group coming? If we take one of the primary hydrogen. So it will be like that, CH2, 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 CH3, and attach it from here. What is the name of this? Just butyl group. This is butyl. But if we take hydrogen from the secondary carbon, what's this called? If it's attached from here, we'll call it secondary butyl group. Secondary butyl group. Here in isobutane, if we take 1 primary hydrogen out, so we'll call it isobutyl, like this one. CH3, CH, CH3, CH2. So it's called isobutyl. But if we take the tertiary hydrogen, this group is called tertiary butyl. Tertiary butyl group. Now we can take like little practice. You know the structure of leucine, isoleucine, and valine, right? Look, all of the amino acids must have carboxylic group, NH2, and side chain. If the side chain like that, what is this called? This is valine. Do you know what's this group? How many carbon? 3 attached from the middle. So this is isopropyl group. Okay, so valine has isopropyl. What about this one? What's the name of that one? Everyone, I think, doing it. Leucine, right? Okay. How many carbon? 1, 2, 3, 4 in the side chain, right? Attached from primary carbon. So this is isobutyl, same like this one. Okay. Isoleucine is like this. 1, 2, 3, 4. How many carbon in isoleucine? Again 4. 1, 2, 3. Oh, sorry. Only 4. We need 4. 1, 2, 3, 4. What's this group called? If I attach it from here. It's attached from which carbon? Secondary carbon, right? So this is secondary butyl, like this one. So isoleucine, secondary butyl, leucine, isobutyl valine isoprop, just to remind yourself. Okay.
Wait, why is it secondary again?
Because if you take this out, okay, so this is a group.
Yeah.
How many carbon? 1, 2, 3, 4. Attach it from secondary carbon. Carbon, attach it to 2 carbon.
So you're talking about the one in the middle now?
No, just,
This one?
yeah, this one, this is secondary carbon. Because it's attached to 2 carbon. Before attach it to the main
Ah.
branch, okay? Of course, after attaching to this one, it will be tertiary, right? Okay, now the nomenclature of alkanes. If we have something like that, CH3, CH2, CH, CH3, CH, CH2, CH3, CH, CH3, CH2, CH3. What's the name of this compound? So the rule, it's called a UBAC system, or UBAC system for nomenclature, International Union of Pure and Applied Chemistry. So we need first to choose where is the parent, find what is the parent. The parent is the longest continuous carbon chain. So if we count like that, 1, 2, 3, 4, 5, 6, 7, 8. Is there anything longer? Like 1, 2, 3, 4, 5, 6, 7. No, this is shorter. 1, 2, 3, 4, 5, 6. So we have to choose this one as the parent. And because it's the parent, so this is like a family name. Must be added at the end, like family name. How many carbon we said? 8. So we have to put 8 at the end, octane. Why it's octane? Because it's alkane. So put A here at the end. Now, what is the substituents? Or the branches coming? We have here one branch. You know it's like a river and has its branches. So we need to know what is the name of these branches. We know the name of the river now, octane, right? But what is the branches coming from it? So we have here 1, 2, 3 branches, right? What's the name of this group? Methyl. So we have methyl. And we have another methyl, right? And what is this group called? 2 carbon? Ethyl. Ethyl, yes. So, from which direction it's better to number, or we have to number? Start from here numbering or from there? We have to give the substituents the least number. So if we start from here, this will take 3, 4, 5. 3 plus 4, 7 plus 5, 12, right? But if we start from here, 1, 2, 3, it will be 3, 4, oh, same? 5. So we can start from each direction, doesn't it? Oh, no, sorry.
Because there's no way.
1, 2, 3, 4,
6, 7.
5, 6. 4 plus 6, 10, plus 5, 15. But from the other direction, it would be 12, right? So what's the least number? 12. So we have to start from the left. So it will be 1, 2, 3, 4, 5, 6, 7, 8. So we have at 3 methyl, and at 5 methyl, and at 4 methyl, ethyl. So we have to put them in the order, alphabetical order. So which start first, ethyl or methyl? Must be ethyl. And always between number and the letter must be hyphen. Okay? And the first letter should be capital. So we need to say 4 hyphen ethyl. And then hyphen Is that correct to say 3-methyl, 5-methyl? If they are the same, we have to put di, 2 di. If 3 tri, 4 tetra, okay? So 3, and between the number and number comma, 3, 5, hyphen, di, methyl, and then one word with octane. Now, E first or D first? D first, right? But we have to ignore die, this word. We have to ignore it. If we say die, try, ignore it. So the first letter is M. Just die because they are 2 methyl. Okay? Okay. What about if we have something like that? CH3, CH2, C, methyl, methyl, C, CH3. And you can complete the hydrogen here, right? So what's the name of this compound? First, where is the parent? So we can count here. 1, 2, 3, 4, 5, 6, 7, 8. I think this is the longest one, right? So we can put like this. And what's the substituents? We have 1 methyl here, and here, and here. Yes, we have to start number from here. So it will be 3, 3, 4, tri, methyl, octane. Right? Because it's 1, 2, 3, 4, 5, 6, 7, 8, octane. Okay, what about if we have something like that? So what's the name of this one? Where is the longest continuous carbon chain? 1, 2, 3, 4, right? Or 1, 2, 3, 4.
5. 1, 2, 3, 4, 5.
1, 2, 3, 4, 5. Yes.
Yes.
Okay, so put here CH2. So which is longer now? Take this one or take this one? The rule said take more substituted one. More substituted. So if we take this one, we have only 2 substituents, right?
Yes.
But if we take this one, so we have 3 substituents. So we need to choose this one. Okay? And numbering, it's created from here. 1, 2, 3, 4, 5. What's the group? What's the name of this group? This is cyclopropane. But if we take one hydrogen, it's called cyclopropyl. So we have 2 cyclopropyl. And we have 4 methyl. And we have 3 ethyl. So which one? And at the end it's at pentane because it's 5 pentane. So which group we start with alphabetically? This C here we need to take it in account. We cannot ignore it. Cyclopropyl or isopropyl. We have to take I in the account. Okay. So 2 cyclopropyl, 3 ethyl, 4 methyl, pentane. Okay? What about if we have something like that? CH3, CH, double bond, CH, CH2, 3. Or we can take one hydrogen from here. And we can put chlorine, for example. Chlorine atom here. So the rule said, or mentioned, we have to choose the longest continuous carbon chain, including the double bond. Even if the double bond is in the chain is not the longest one, but we have to include it in the pair. Okay? And give the double bond the least number. So if we started from here, the double bond will take 3 and 4, right? But if we started from here, the double bond will take 2 and 3. So from where we have to start? From this one. So it's 1, 2, 3, 4, 5. So at the substituent here, we have 4 chloro. 4 chloro here. And then the double bond takes the least number. So 2 and 3, so we'll call it 2. If it's between 3 and 4, we'll call it 3. So we have 2 options. We can say 4 chloro 2 benzene or 4 chloro bent 2E. Both are correct. Okay? Because En, this represents the double bond. So we can say 4 chloro 2 benzene or 4 chloro bent 2E. Okay? Okay, another example. CH3, C triple bond C, CH, Cl, CH3. So this is the same like alkene. But instead of En, Yn. So again, 1, 2, 3, 4, 5. So it will be 4 chloro, 2 pentyne, Yne, or bent to I, same. Okay, same like here. Now we can make it like more tricky. What about if we have something like that? Compound with 2 function groups. CH, triple bond, C, CH2, CH2, COOH. Which has more priority in numbering? Carboxylic group, this is called the carboxylic group or alkyne group. So the highest priority it will be for carboxylic group. So we have to start numbering from here, from the carboxylic. So it will be 1, 2, 3, 4, 5. How we can name the carboxylic acid? I made this example because you are using it a lot in the but still we didn't go through the carboxylic, but we can say it quickly. The carboxylic group acid, something like that, CH3, COOH. How many carbon here? 2 carbons. So again, we need to go back to ethane. Because if it's alkane, so we'll call it ethane. But if it has carboxylic, take out E and put OIC acid. So it's called ethanoic acid. This is how to give a name for carboxylic acid. But of course, the common name is acetic acid, right? But the Eubank name is ethanoic acid. What about formic acid? HCOOH. This is called formic acid. How many carbon? 1. So it's methane. Take out E, put OIC. So it's called methanoic acid. So formic acid also called methanoic acid. So how many carbon here? 5. So instead of pentane, what's the name? Bentanoic acid. Bentanoic acid. But we have alkyne here. So if it's alkyne, we need to say 4 because it's between 4 and 5. 4 pentyne. 4 pentyne, right? And at number 1, there is oic. Oic means carboxylic. Bentanoic acid. So 4 bentanoic acid or 4 bentyne 1 oic acid. I think all of you used it for Killick reaction, right? use it for chemistry. It's called 4-bentanoic acid. We can also take out one because carboxylate must be number one because it's terminal, so it has to be number one. Attach it only to one by one bond, so it's called 4-bentanoic acid. Okay. So which is more reactive? Alkane, like butane for example. Butane is more reactive, or butene? Which is more reactive? So to know which compound is more reactive, we need to see where is the function group. In alkane, there is no function group, so it's very unreactive. All of the alkane are very unreactive because there is no function group. It has only one chemical reaction, which is free radical reaction. If we react it with alkane, with chlorine or bromine in presence of light. But here is double bond. This is the function group. See double bond C. This is alkene. And this is the function group. And this is why alkene is reactive. And how is the function group formed? So, as we said, any carbon attached or surrounded by how many bonds? 4 bonds. But doesn't need to be attached by 4 atoms. Right? For example, this carbon has attached to 3 hydrogen and 1 carbon. So it's attached to 4. But this carbon, how many atoms attached to it? Attached to carbon here, hydrogen, carbon. So only 3. So there is difference in hybridization of this carbon. If carbon attached to 4 atoms, it's called sp3 carbon. But if it's attached to 3 atoms, it's called sp2 carbon. But if attached to only 1 atom, like in alkyne, so this is sp carbon. So this is the number of atoms attached to sp3 carbon, sp2 carbon, sp carbon. Okay? The angle between bonds in the sp3 carbon is 109 degrees. So if you look at methane, for example, it looks like that. So this is a carbon of methane attached to 4 hydrogen atoms. So this is called tetrahedral because if you put line like that, so it's tetrahedral, right? And the angle 109 degrees. But if it's hybridization sp2 carbon, so the angle is 120 degrees and it's planar. So it will be like that. So look at butene, 2-butene. This carbon attached to methyl and the hydrogen, methyl and the hydrogen. So look, the angle is 120 degrees and the compound is planar. Okay? But if it's sp carbon, so it will be linear, like in acetylene. And the angle is 180 degrees and also planar. This is why it's very bad if you draw your structure has alkyl group and make it angled. Must be planar or linear, sorry, linear. So if you draw compound like this, for example, CH2 or CH2 C. It's very bad if you draw it like that. Okay? Because alkyl and sp carbon must be linear. So it must be like this. So you have to double check your drawing in the chem drawing. sp carbon must be linear. Okay? The difference in electronegativity between carbon and hydrogen, it's very important in the reactivity of the compounds. What's mean by electronegativity? Any bond formed from two electrons, right? It's called covalent bond. So carbon atom shared with one electron, and the hydrogen shared with one electron, and they make covalent bond. Okay, it's right?
Yeah.
You understand it?
Yeah.
So if the carbon is sp3 carbon, so the ability of the affinity of the atom to attract electrons, it will be the same like hydrogen atom. They have the same strength in the ability to attract electrons toward each cell. This is the electronegativity, affinity of atom or nucleus to attract the electrons toward itself. But because the carbon and the hydrogen, if it's sp3 carbon, same electronegativity, so the electrons will stay between them. So this bond is not polar bond. There's no positive, no negative. But for the hydrogen attached to sp carbon is higher in electronegativity than hydrogen atom. So we'll find that these electrons attracted more towards the carbon and make partial negative charge on the carbon atom and leaving partial positive charge on the hydrogen atom. And we'll call this bond is polarized bond. Polarized means has a polar side positive and another pole is negative. And this makes this bond weak bond because it's a polarized bond, easy to be broken. And this is why this hydrogen, we call it acidic hydrogen. It's easy to be taken by a base. Okay? Any strong base can abstract this proton. What's the definition of the base, especially if we talk about pronested base? What is the pronested base? Pronested base is an agent or group has the ability to abstract hydrogen, or abstract proton, because it will take hydrogen as proton, like H+, and it will leave the negative charge here. The bond, it will stay on the carbon. Some examples of pronested base, hydroxide group, for example, OH negative. So OH negative can take the hydrogen and make water, and leaving the two electrons on the carbon making negative charge. It's called acetanilide. This is the nucleophile coming from this reaction. Okay? So it's important to know that sp carbon has the highest electronegativity carbon, and sp3 carbon has a very low electronegativity, exactly the same like hydrogen atom. And sp3 carbon are tetrahedral, so they are not planar. Planar means we can do the structure on a table like that. But they are 3 dimensions because they are tetrahedral. But it's important for stereochemistry to know that. But sp2 carbon and sp carbon are planar, and this is linear even. Okay? So anyone can tell me carbon dioxide, what's the hybridization of carbon? It's like that. This is the structure of carbon dioxide. How many atoms attached to the carbon? 2. So it's sp carbon, and it's linear. Okay. Even it doesn't have triple bond, but you need to count how many atoms attached to the carbon to know the type of hybridization. So it's a linear sp carbon. So for molecule like butene or like ethylene, for example. Ethene or ethylene. This alkene, very simple alkene. This is the first member of alkene. How is the bond formed between the atoms? So, carbon atom has 6 electrons, right? And these electrons distributed like that. In, there's a nucleus and 2 energy levels. First energy level has 2 electrons, and still another 4 in the second energy level. So in the first energy level, there is only one type of orbital. It's like a ball, like sphere. It's called s orbital. Okay, and because it's in the first energy level, we call it 1s. So in 1s, each orbital can take only 2 electrons. And in the second energy level, there are 2 types of orbitals. There are s orbital and p orbital. And because in the second level, we call them 2 and 2, 2s, 2p. And what is the shape of the orbital, s orbital? It's like sphere, right? Like sphere. And it has also 2 electrons. But p orbitals, it's 3 orbitals. And they are like dumbbell shape, it's like that. And little tail here. Dumbbell shape. So only 2 electrons left. And the orbitals is x, y, z. Or maybe p orbitals like that, like this, dumbbell shape. And the nucleus in the middle, surrounded by orbitals, surrounded by s orbital, all of them. Okay. And at the beginning, before forming any bonds, one of the electrons from 2s excited. Excited means take energy, and migrated from 2s to 2pz. So it will be after hybridization or after excitation, it will be like that. 2s has only 1 electron, and 2p has 3 electrons. In ethylene, how many atoms attached to the carbon? Look, it's like this, CH. So the carbon attached to only 3 atoms, right? So we need 3 orbitals. Each orbital has 1 electron to be able to attach to the 3 atoms. So what will happen? Hybridization will occur now. The s orbital with another 2p orbital will be hybridized, mix it together. Mix it like we can bring a scissor and cut each one into 3 parts. 3 parts. Then take 1 part from that, 1 part from that, 1 part from that, and make a new orbital. What's the name of this new orbital? Which would be? So if it's coming from one of the s, and how many b? 2b. So it's called sp2 orbital. Okay? And still we have another 2/3, 2/3, 2/3. They will make another 2 sp2 orbital. And this one, which is bz, is not included in the hybridization. Has 1 electron. And this one also not included in the hybridization. And the shape of these orbitals is like this. It's a mix between sphere and dumbbell shape. Okay? And as we said, it was the angle 120 and the planar. So the carbon atom, it will be surrounded by 3 orbitals, new 3 orbitals. sp2, sp2, sp2. Okay? This is planar, triangle and the planar, like triangle and the planar. We can draw it like that on the table. Okay? What about the other carbon? The same. The other carbon also has 3 orbitals surrounding it, like this. We said each orbital has 1 electron. So when these 2 orbitals overlap together, so the overlap will happen between the heads of the orbitals. This is why the bond will be very, very strong. It's called sigma bond. So this is how the covalent bond forms. It's overlap between 2 orbitals head by head. Makes sigma bond. And the hydrogen atom, hydrogen only has 1 electron in 1 s, so it's in a sphere or ball. So it will make overlap here, make sigma bond, sigma bond, sigma bond, sigma bond. What about the second bond, pi bond? So still we have BZ. BZ is perpendicular on the triangle, like that, okay? So we need to make a hole in the hole like this. So we can draw it like that. So they will make side by side overlap from like a sandwich for the molecule. It will overlap side by side. And this will make weak bond called pi bond. Okay? So this molecule, how many sigma bonds? Each bond single, this is sigma. So this is 1 sigma, 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 sigma. And the second bond, it will be pi. Okay? So we have 5 sigma bonds and 1 pi bond. But if we have something like that, acetylene for example, this is sigma, this is sigma, the middle one sigma and 2 pi. Okay? 2 atoms cannot be attached with more than sigma. Only 1 sigma and the rest it will be pi if it's multiple bonds. 1 sigma, 2 pi. But here 1 sigma, 1 pi. Okay? Why I draw this structure? Why I went through the hybridization? Just to show you that any group try to come closer to this molecule. It should be positive or negative? It should be positive because the 2 carbon atoms surrounding pi very high density of electrons of the pi bonds, and they are loose, not held strongly. So any atoms or any group come close to it. If it's negative, repulsion. If it's positive, attraction. Okay? This is why the reaction of alkene called electrophilic reaction. What's meant by electrophile? Electrophile, phile mean like or love here, like electrons, like negative charge. So it must be positive. And we give it a symbol like this, E positive, electrophile. So any group or atom come close to the alkene must be electrophile. This is why all of the reaction, or most of the reaction of alkene is called electrophilic reaction. I think we can continue next time. I think you feel tired and we